Hi, I'm a master's student and I'm majoring in computer science, and this is layered motion. We're going to be talking about what is layered motion and how it helps us in our models and how to identify it. It's a pretty new and upcoming topic with the as you move on from image classification and you come on to videos. And we're also going to play a little exercise in the end. I was going to say game, but it's not a game. It's a little exercise in the end where we try and identify what the model is going to detect and how it does it. So let's get started. So what is layered motion? So let's look at a couple of examples here. You have your example A, B, and your C. This is all one example, and the difficulty of this problem is simple in terms of how the computer or your model takes in the layered motion. So you have your hand which is waving, and then you have your background, and then you have your line segments which says um, what is the direction of the motion. So this is a pretty simple thing to do if you have a solid background and there's only one thing that is moving. It's easy to identify that, okay, this is a moving hand, so this is where the motion is happening, and this is the background. Let's go towards a little difficult problem. So this is like a wide shot view of a truck and a car in between trees, like a forest area. The both of them are going, I was gonna say relatively same speed, but you can see the car is coming up from behind, then it is with the truck, and then it passes the truck. So why is this hard is because you have your background is very distorted because this image is taken from far, or this video is taken from far. These four images are also from a distance. Then it is because you're not really sure, the algorithm or the model might mistake the truck to be a part of the background as well. Maybe it is not, maybe it is, you don't know, because truck is in, if you see the four images, it's right about the same place, but there's like very limited movement, so you can't really judge if that it is. And then if you look at the red car and image 3, it kind of almost hides in the bushes, and you can say that's lost, and it can identify this as a different image, or like it can say this red car is not the same car that was in the frame 2 seconds ago, and that red car just disappeared and this other red car appeared out of nowhere. So that's what makes it really difficult or hard. And this is an extreme model. This is also taken from a distance, and you can see the image is very noisy. You don't know what we're tracking. Are we tracking the cars? Yes, these are cars on the road. Are we tracking the building? The camera is also moving. A building that was there before is not there now. So this is a very difficult model. This is a very difficult video to analyze and to see where the motion is happening exactly. So this is layered motion and the difficulties that we face, and the solution to all of this is to get a better computer vision model and to create a better layered model. So again, this is another example where we have so this exactly is in motion, but the first step is to take an image and to identify various aspects of it, or rather identify what is foreground and what is background. So here you can see with the color scale, it's identifying the toy soldiers and like a couple of knickknacks, or like the two figurines in front of the bag, or like this cupboard which appears to be closest to the camera as foreground, whereas everything else it is identifying as background. And then also sensitivity comes into picture of how sensitive you want your background to be, or if it's just one or couple. So that's another thing that you have to deal with when you're coming up with layered motion. So here is another whatever I said just into like a couple of words. You can pause this video if you want to read this, but yeah, it's mostly about background, foreground, sensitivity, and what is what. So this is another problem. These four images are similar, almost the same, maybe a little different as the camera pans from left to right. We can see that from E to H it identifies, so we can see E and G are pretty much the same, but F, if you consider F and H, it has wrongly identified a couple of images and it is not able to figure out what is the background and what is the foreground and what is the object. So here's another solution, is to come up with a smooth flow field and to analyze what is, take into a wide range of motions like translation, rotation, and zoom. So it's a little difficult than it comes off to be. Here are a few. So we define an affine motion, and these are the parameters that it needs to follow. So if you're looking more into mathematics of this, these are two really important equation. If you're looking this for getting understanding, you can just say that it's just summation of velocity, components of velocity taken, and the entire as a whole, which gives us the affine motion parameters. So this is the analysis. If you're looking at three dots all clubbed together, we can say, so here we have the velocity estimates, the velocity smoothing, which is just a curve to make sure most of the dots are as close to the curve as possible. Then you have your regularization, where you make sure that each dot is a part of the curve. And then you have your reverse estimation. So you have two separate layers, and based on what the model it is that you're using, you can define what curve you want. So the main takeaway from the principle of layered motion is rendering is easy, but vision is difficult. So again, this is an image with tree being in the foreground, houses being in the background, flowers also you can see almost in the background, and the flow image, if you can look, it's like a bunch of dots and dashes. So darker dots represent something that is closer to the camera, whereas the lighter dots would be farther away. Then you have your initial layers and your final layers. And yeah, so if you can identify what is your object and what is your background, you can very well play with it, and you can like insert an object and remove an object. That makes it easier. So this is a Wang and Adelson approach. So what it has are like these goals. So represent moving images with a set of overlapping layers that are ordered in depth and occlude each other, velocity maps that we discussed earlier. So you have your intensity map, alpha map, and velocity map. So again, coming back to this hand, the easiest that we have, easiest example that we considered. So you have your intensity map, which is just helps us with our background layer. It tells us how far it is from the camera. Your alpha map, your velocity map, same thing. Velocity map gives us direction, alpha map gives us the object, and if these three maps are taken together, you have your sequence of motion. So we have different approaches for motion estimation, motion segmentation, and then you have, of course, your hypothesis testing, your layer synthesis. I'm just gonna go through these slides because they are very detailed, and if you're going into this topic, if you want to be very detailed with this topic, then you can go through and read this. But if you just want an overview, then that's fine. So yeah, now like coming to our yeah, I'll try to find this basic optic flow and dense optic flow programs if I have. I'm not sure, but if I don't find them, I'll just link them in the description. If I do find them, I'll just link them in the description. Now we're gonna play the game slash activity slash exercise. If you understood layered motion well, we have this woman who's running towards the camera. So which part of the picture gets highlighted? Pause the video if you think you require more time. Yeah, so the thing that has been highlighted is the woman and nothing else, even though it's a moving shot, I believe it's called, or if the camera is moving, still the woman is the one that's been identified. So if your background has been identified well, it would successfully detect that this is the background and the woman is the object. So here we have a cat jumping out from a window. So which part of the picture gets highlighted? The cupboard, the cat, or the table? And the answer is the cat. Again, now here on the other picture, here the options are, you have a tennis player, racket, the tennis player and the racket, or is it going to be the feet and the racket? So you have your tennis player and the racket that's been identified. Now you have a man who is dialing using an old telephone. So what would get highlighted? The telephone, the hands of the man, or the man in the telephone. So I'm not sure if this picture is clear or not, but the answer is the man and the telephone. The telephone gets identified more because that's the object that is actually moving. But if you consider a frame of reference, the man himself is going to be moving in the shot, so he will also be identified. Here we have our last image of a juggler. Well, you have not exactly a juggler because he's juggling with just one ball, but what is going to be highlighted? The ball, hands in the ball, just the hands, or hands, ball, and the desk, since desk is in the foreground, as in desk is the closest object to the camera. And if you can see here, you have the ball and the hands of the juggler. You can see something else that has also been highlighted, which is, I believe, the shirt of the man, but that could be because he's kind of also moving, but compared to his hands and the ball, the motion is very minute. But yeah, the model has got a little bit of the shirt as well. Thank you for watching, and I'll see you again next time.